Question 15, it's a paper 1 question. These 3 terms are consecutive values of a sequence, a sub n, k squared, and the second term is 6 plus k, third term is 12 minus k. Find the value of k for which this sequence is a non-constant arithmetic sequence stating its general term. Well, they said it was an arithmetic sequence, so the difference must be the second u2 minus u1 should equal u3 minus u2. So we've done that here. We resolve it down to 3k minus k squared equals 0. Take the k out. We've got 2 of these with the null factor law. But k equals 0 or k equals 3. Now it says it's a non-constant arithmetic sequence, so k can't equal 3, because if you put 3 in there, you've got 9, 9, and then 9. So they would be constant terms there. So it is a non-constant arithmetic sequence, so we can't include 3, but we can include 0. And those terms would be 0, 6, 12, and with a difference of 6, obviously. The general term, using our formula for an arithmetic sequence, is u1 plus n minus 1d. u1 is 0, n minus 1 times 6, and so that's 6n minus 6. That's a little bit different from the book, but I prefer this one. We started with our first term is actually u1. I think they started with u0. Question 16, it's a paper 1 question. A company is considering producing a new product. The new production requires installation of new machines and equipment. For this purpose, the company wants to borrow money by selling bonds, each priced at US $100,000, lasting for a 10-year period. The interest which the company pays to the bondholders is 5% per year. Calculate the amount of interest to be paid per bond over the 10-year period in each of the following cases. Give your answers exactly or correct to 2 decimal places where necessary. A, simple interest is charged. We use the formula for simple interest, which is the principal by the period by the interest rate. That's 100,000 by 10 by 0.05. The answer is 50,000. $50,000 for the simple interest. B, interest is compounded annually. Well, remember that we're finding not the interest, but the future value here. That's the present value, 100,000 times 1 plus 0.05 to the 10. The reason we're using 10 is because interest is accrued in the first year. So we resolve that. We have the future value is 162,889.46. The interest is the future value minus the present value, and the answer is 62,889.46, 2 decimal places, because it's money. C, interest is compounded monthly. Okay, so we're using the general formula with K. K is 12, and we get $164,700.95. Remember, the interest is the future value minus the present value. That's $64,700.95. Question 17, it's a paper 2 question. In this question, give all answers to 2 decimal places. Carlos decides to take out a loan of 20,000 Peruvian sols to buy a car. His bank offers 2 options to finance the loan. Option A, a 5-year loan with an annual interest rate of 12.8% compounded quarterly, no deposit required. B, a 5-year loan with an annual interest rate of R% compounded monthly. Terms of the loan require a 10% deposit and monthly repayments of 400 sols. A, if Carlos chooses option A, find 1, the repayment he makes each quarter. Okay, so I've set this out like we have in the calculator. All right, now we need to put the numbers in here for the calculator. Remember, make sure you do this when you use the GDC. Now, we want to keep these as 1 and 1, so we're going to adjust n and the interest rate. So it's quarterly, so we've got to multiply the 5-year by 4, and we divide the interest rate by 4 to get the quarterly interest rate. The present value is 20,000. The future value is 0, and we put it in the calculator. We get a payment of minus 1369.29. Therefore, he would pay 1,369.29 sols each quarter. And remember, because that payment is a negative number, he gives the money away. He doesn't receive the money. If that's negative, he gives it to someone. Let's have a look at number 2, the total amount he pays back. Well, the total repayments will be 5 years, and there's 4 quarters, and this was the quarterly payment, so it's 1369.29, and it's 27,385,888,530. Now, I did this calculation here for accuracy. I went back and I made sure that I put in all these extra numbers as well. I used that from the calculator to get an accurate answer here, and it was 27,385.89 sols. 3, the total interest he pays on the loan. Well, the total interest is the total repayments minus the present value. So that would be 27,385.89 minus the present value is 20,000. So it's 7,385.89 sol. B, If Carlos chooses option B, find 1, the total amount Carlos pays to the bank. Okay, remember this is option B now, so he has to give a 10% deposit, so that's 20,000 times 0.1, that would be 10%. Plus, he's also paying back 400 monthly repayments, so it's 400, 5 years, 12 months, so it's 26,000 sold. 2, the annual interest rate R. Now we have to find R. All right, we'll set this out like it is in the calculator. We want to keep these two as 1 and 1, so we're going to adjust N and the interest rate. It's 5 years and it's monthly, so it's 5 times 12. The calculator is going to give us 1/12 of R. That number we get from the calculator would just be 1/12 of R, so we'll need to multiply it eventually by 12. The present value isn't 20,000, it's 20,000 by 0.9 because we paid a deposit of 10%. The payment is negative because we're giving the money to the bank. Future value is 0. Put it in the calculator, we get an interest rate of 0.996333794. Remember, R is 12 times that number, which is 11.96%. C, state which option Carlos should choose, justify your reasoning. Under these conditions, option B, because the total amount he pays to the bank is less. Question 18, it's a paper 1 question. Consider the graph of the exponential function f defined by function equals 16 minus 4 times 2 to the minus x. A, state the domain of f. Well, the domain are the x values here, and we can see that they're all real numbers. Okay, there's no exclusions there. It's the whole number line, so it's all real. B, state the 0 of f. Now they're asking here when the function equals 0. The function equals 0 at x equals minus 2. Okay, because that's when the function equals 0 there. C, state the y-intercept of the graph of f. Well, the y-intercept is when x is equal to 0. We're looking for that value right there. We put 16 minus 4 times 2 to the 0. That equals 12. D, state the range of f. All right, so the range is the y values. Now we know it has an asymptote here at 16. From the equation we can see that's 16. That's indicating the asymptote is at 16. So it never reaches 16. Y is less than 16 is the range. E, state the interval where f is positive. So we're looking for where the function is positive. Well, clearly from the graph you can see the function is positive. It's above the x-axis from minus 2. So the function is positive in the domain x is greater than minus 2. F, state the equation of the horizontal asymptote of f. Well, as we said in D, the horizontal asymptote is at y equals 16. We know that from this, that constant there. Okay, that shows that normally the asymptote's at 0, so this shifted it up by 16. Question 19, it's a paper 1 question. In a controlled experiment, the temperature T of a liquid T hours after the start of the experiment is T equals 25 plus e to the 0.4 T. I think there's a misprint in the book. I've shifted that T up to 0.4 T. The domain here, because T is on the x-axis, is T is greater than or equal to 0 and less than or equal to 12. A, sketch the graph of the temperature. Okay, now I've taken it out of the back of the book. Looks good. Make sure it's all labelled. There's probably, you should have degrees C over here. They don't have that in the book. It should have the units, and here we've got hours, so that's great. Okay, you should also indicate that point where it crosses axes. You should write down, they give points for that. So I would write down that point on the graph, and also, well, that would be when T equals 0, and also write degrees C to make that a bit snappier. B, state the temperature halfway through the experiment to the nearest 0.1 degrees C. Okay, so it says halfway through the experiment. So if the experiment ran from 0 to 12 hours, then at 6 hours, we need to look at that. So we use the formula that was given as 25 plus e to the 0.4 times 6, because we said 6 hours. That temperature is 36.023. It said to the nearest 0.1 degrees, so the temperature halfway through is 36 degrees C. Now talking about C, here's C. Find the time at which the temperature of the liquid reaches 100 degrees C. Give your answer in hours and minutes to the nearest minute. All right, back to the formula. Now that we know the function, when that equals 100, we've got 25 plus e to the 0.4 t, and I've just minus the 25 from both sides. We've got 75 equals that. I took the logs, log of 75, and I've used log e so we can get rid of that. So I'm using log base e equals log e to the 0.4 t. Remember, you can bring down that exponent to the front. Log e of e is 1. So you got log of 75 equals 0.4 t, t equals log of 75 on 0.4, and we get 10.79372. If you use the GDC solve function, you also get the same number. That's 10.79 hours. That's 10 hours plus 0.79 times 60 minutes. That's 10 hours 47.4 minutes. And it says to the nearest minute, so it's 10 hours 47 minutes. 20, paper 2 question. A controlled experiment took place in a laboratory. Biologists estimated the number of microbes N present in a culture T days after the start of their experiment. The first results obtained are shown in the top 2 rows of the table below. T there is in days, that should be written in the table really, and N is the number of microbes. It's increasing there. It says A, complete the last row of the table. So this is the last row here. We need to complete that table there. So basically we just have to use our calculator and get the log values of that. And I just grabbed them from the back of the book, and they're the numbers there. So that's this table. This row is that row there. It's the log of N. B, draw a graph of log N against T using appropriate scales. Okay, this has also come from the book. Draw a graph of that log N against T, of log N against T using the appropriate scale. So we've got Y here, we've got X. Okay, and that's the mark scheme there. All right, so we know that Y is representing the log number, so that really should say log N there. And T along here, this is time along here. Remember, it was log N against T. They really should put T there. C, hence state the type of model that best fits the data displayed in part B. So it's looking like a straight line. Okay, so linear model. D, Dr. Wise claims that the number of microbes can be modeled by this. That's our standard form for exponential. Explain why Dr. Wise is correct. From the graph, we can see that the log, the y value, equals a plus bt. Now, the reason we can say that is because it's a straight line. This is the general form for a straight line where b is the slope and a is the y-intercept. Now, knowing that, and this is a base 10, so it's 10 to the power of that equals n. These are equivalent. Okay, now we can break that up to 10 to the power of a times 10 to the power of bt equals n. And Dr. Wise's model was a times b to the t, and a is this constant 10 to the a, and b is equal to 10 to the b. So there's b to the t there, okay? E, hence determine the values of the parameters a and b of Dr. Wise's model showing all your calculations. Okay, we use the graphic display calculator and we use linear regression. Now remember, this is t and that is log n. So our first column is the independent variable t. So we put that in the calculator, and log n is column 2. Then we do the linear regression and it comes up with these values here, 1.91868 plus 0.06691t. So these values are separate, but from the calculator you just put them in as a plus bt here. So a equals 10 to that, and b equals 10 to this. So a equals 82.92395, or 82.9 are 3 significant figures, and b is 10 to the power of 0.06691, which is 1.166568, or 1.17 are 3 significant figures.